All right, so for this video, I want to state a theorem. So an isolated singularity, z0, of a function f is a pole of order m if and only if f of z can be written in this way. You can write f of z as some other function phi of z over z minus z0 to the m. So if f has a pole of order m at z0, I can write f like this, and this is really important, where this other function phi is analytic. Number one, it's got to be analytic, and number two, phi of z0 can't be 0. You need both of those. So in this case, i.e. when f does have a pole of order m, then phi actually tells you the residue. So the residue of f of z at z0 is, well, if it's a simple pole, it's just phi of z, and if it's a non-simple pole, it's the m minus 1 derivative of phi. So I'm assuming a pole of order m, then the residue of f is the m minus 1 derivative of phi evaluated at z0 over m minus 1 factorial. By the way, it should be somewhat clear to you, I could combine these and just have one case. This actually covers it even for m equals 1. You just have to interpret phi. The zeroth derivative of phi is just phi, and then we want to do 0 factorial is just 1, and it actually works. So I don't have to separate these cases. I did just to try to make it clear. So a couple of examples, and then I'll let you guys go, and we'll be done with this lecture. So the first one, this function, z plus 1 over z squared plus 9, has an isolated singularity. So let's just say that this has an isolated singularity. Well, there's actually two of them at plus or minus 3i. Let's look at 3i first. So an isolated singularity at z equals 3i, and it can be written as, well, f of z equals phi of z over z minus 3i with phi of z. What's phi of z? Phi of z is the other part, z plus 1 over z plus 3i. And if you recall, we did a very similar trick here back when we were looking at some integrals back in chapter 4. And then we just need to make a few notes. So we need to note that phi is analytic everywhere except at negative 3i. So it is analytic at z equals 3i. And just as importantly, phi of 3i, you can check it's not 0. And so that means I could write it as phi over z minus 3i to the 1 power. So now I know that f, looking at f now, f, whoa, the iPad just messed up my f. So f has a simple pole at z equals 3i. And by the way, what's the residue? So with residue, well, the residue at z equals 3i of f is just phi of 3i. So you just plug 3i into phi, and so you get 3i plus 1 over 6i, which of course you can simplify to 3 minus i over 6. And I'll just squeeze in here at the top. Similarly, one can show, I'm not going to work it out, but there's another singularity at z equals negative 3i. So one can show that z equals minus 3i is also a simple pole. Let me zoom in a little bit. I didn't realize that I wasn't zoomed in. Is also a simple pole with the residue at z equals minus 3i of f equals 3 plus I over 6. So I'll stop this video here, and then in the next video we'll just do 2 more examples, and then we'll call it a lecture.